One type of bond that holds molecules together is an ionic bond, where the attraction between oppositely charged ions is what holds them together. So let's take a look at sodium and chlorine atom and recall what kind of ions they like to form. Focusing on the valence electrons, recall that sodium has that one valence electron in its third orbital that it likes to get rid of. And recall that chlorine has 7 valence electrons, and it likes to pick up one extra electron for that stable outer orbital, fulfilling the octet rule. So, sodium often gives up its electron to chlorine, forming the sodium cation, a positively charged ion, and the chloride anion, a negatively charged ion. Thus, that interaction between the two oppositely charged ions forms sodium chloride, or otherwise known as table salt. So this is an example of an ionic bond, the giving up of electrons by one atom and the acceptance of those electrons by another, and then simply being held together by the electric attraction between the two. Ionic compounds are often referred to as salts in general, so other than just sodium chloride, which is our typical table salt, all sorts of ionic compounds are typically referred to as salts. And one of the characteristics of salts is that when they're placed in an aqueous solution, water, which makes up most of biological fluids, they dissolve easily because of the properties of water. And when they dissolve, water tears that ionic bond apart, releasing the individual ions. So if we add some sodium chloride, for instance, to water, we would then see that that sodium chloride gets torn apart. Those ionic bonds are broken up by water, forming the resultant ions, sodium ion and chloride ion in solution.
So what I'd like you to do now is pause the video for a moment and take a look at these two molecules, lithium fluoride and magnesium chloride, and tell me which ions will form when they're placed in water. You have the relevant information from the periodic table to the right, so take a moment to work on that now. Alright, recall that lithium has that one single valence electron in its outermost shell that it likes to get rid of, forming the lithium cation, which is a +1 charge. Fluorine has 7 valence electrons, and it then likes to gain that one extra electron to satisfy the octet rule and have a full outer valence shell. That creates the fluoride ion with a -1 charge. So these are the two ions that will form when lithium fluoride, that salt, is placed into water.
Now, magnesium chloride, first of all, what I want you to notice is that this molecule is 3 atoms, 1 atom of magnesium and 2 atoms of chlorine, as you can see from the way it's written at the top there. Okay, so recall magnesium is atomic number 12, meaning that it has 12 protons. When you fill out the orbital diagram, you see that it has 2 valence electrons, and it likes to get rid of those 2 electrons to form that stable outer ring, full octet, and thus if you're giving up 2 negative charges, magnesium ion itself is a cation with a +2 charge. Now we've already been through chloride ion a number of times now. We know that it likes to form that -1 charge chloride ion, and thus we see that to balance those 2 positive charges of magnesium ion, it will attract 2 chloride ions, each carrying a -1 charge. Thus, when dissolved in water, magnesium chloride will form these 3 constituent ions you see at the bottom.